Hello there, welcome to SibaLearningZone.com. This is the last of our topics under experimental techniques. Today we're going to talk about methods of separating mixtures. Now in our previous lessons, we learned that a pure substance is made up of only one type of atom or molecule. In chemistry, a pure substance is different from what we know in normal life. A pure substance does not mean it is clean, but it means that it is made up of only one type of atom or molecule. A mixture is made up of two or more substances. The types of mixtures are gas-gas mixture, liquid-gas mixture, liquid-liquid mixture, liquid-solid mixture, and solid-solid mixture. Clearly you can see the three states of matter here. We have gas, we have liquid, we have solid. So for gas-gas mixture, we can talk about air. Liquid-gas mixture, we can talk about the carbonated drinks. Liquid-liquid mixture, we can talk about juice and water or diluted juice. Liquid-solid mixture, we can talk about solutions like salt and water. And then solid mixture, we can talk about any two solids coming together. So sand and salt is a solid mixture. The presence of impurities affects the melting and boiling points of water. When you have pure water, its boiling point is 100 degrees Celsius. But when you mix it with other substances like salt and other things, the water's boiling point changes. Now let's see how we can separate these mixtures. The first one we're going to talk about is filtration. It is a method used to separate a mixture of liquid and insoluble particles. So clearly here we have liquid and solid, okay, and these solids are insoluble. Now this is what we do. We get our funnel and then we put our filter paper. We use our filter paper to line the funnel. Then we pour the liquid into the funnel. Okay, so we have the funnel. We use the filter paper to line the funnel, and then we pour the liquid into it. Now the dirt will be collected on the surface, and then the filtrate will be collected in the glass jar. So this is our filtrate, and this is where the unnecessary insoluble particles will be collected. Okay, so this is for filtration. And then the most important thing is that it is used to separate a mixture of liquid and insoluble particles. So we have liquid and solid mixture, liquid solid mixture, but this time around the solids are insoluble. We go on to decantation, and then it is used to separate a mixture of liquid and insoluble substance, just like filtration, but this time around the insoluble substances could be much heavier and larger. Okay, so for an example is water and sand. The insoluble solids are allowed to settle at the bottom of the liquid. The liquid is poured off, leaving the solids at the bottom. So the sand particles are heavier. We allow the mixture to stand for a while, and then all the heavy particles will settle at the bottom. Then we can clearly pour our liquid out and then separate the two of them. If you want the sand, we just dry the sand and then we get our sand too. The next one is crystallization, producing crystals. Now it is used to create pure crystals of a solute in a solution. Example is creating copper 2 sulfate crystals. Now copper 2 sulfate is a pale blue compound. Now when you mix it with water, you get this pale blue solution. Now if you want our copper 2 sulfate crystals again, we evaporate the solution to get rid of some of the solvents, and this makes the solution more saturated. When we say a saturated solution, it's a solution that has more solutes than can dissolve. So when you take salt, when you put salt in water, the salt dissolves. But if you keep adding the salt, it will get to a point where the salt is no longer going to dissolve, and that is what we call a saturated solution. So when we evaporate some of the water from the copper sulfate solution, the solution becomes saturated. Now we leave the solution to cool, and then the crystals are going to be formed. Sometimes we can seed them. Seeding is when we take a copper crystal, we tie it with a rope, and then we place it in the solution. So let's say we have our copper crystal here. We tie it with a rope, and then we place this in the solution. Okay, so we place this in the solution, and then the new crystals will start forming around it, and this is what we call seeding. After they've been formed, the crystals are filtered to remove the solvent. So we pour it through the funnel, just like in the filtration, and then we get our copper crystals. Simple distillation. This time around, we're dealing with a solvent and a solute. Remember, this is also for solid liquid mixture or liquid solid mixture, but this time around the solid has been able to dissolve in the liquid. In the first two, decantation and filtration, the solids were not dissolved, they were just in there, so we filtered out or we poured off the liquid part in decantation. Now we can separate this mixture, a solvent and a solute, by distillation. Example is distilled water. Now when you take water, running water, normally it is mixed with other chemical components. As it passes over rocks, it is mixed with minerals in the rocks. Now we can get distilled water by this process. Now the mixture is heated in a round bottom flask. The mixture is heated in a round bottom flask. The thermometer here is just to check the temperature. As it is heated, the water will evaporate. The water will evaporate. Now once they evaporate, this has been closed over here. So the evaporated water is forced down this tube, down this delivery tube. As it comes here, there is cool water in this condenser, so it changes the evaporated water back to liquid. So first, in distillation, 1, evaporation takes place, and then 2, condensation. So in distillation, we're talking about two processes that have been combined: evaporation and condensation. So please don't forget, distillation is just evaporation and condensation combined to form one process. Please forgive my handwriting here. Now let's see fractional distillation. It's just like the distillation, but this time around we are breaking one component into small bits. Okay, we are breaking one whole thing into small bits. When you have pizza and then you take one section out of the whole thing, you've just taken out a fraction. Now here we have our liquid. An example is crude oil. The crude is our whole liquid. We can separate these different parts of the liquid, giving us the crude oil, by fractional distillation. Now the advantage over here is that these liquids have different boiling points. So as you heat the crude oil, it gets to a point where the boiling point of petrol is reached, and then it will evaporate, we condense, and then we get our petrol. The boiling point of diesel is reached, it will evaporate, and then we get our diesel. Gas is also produced, it evaporates and then collected. So this method is used to separate liquids with different boiling points. The mixture is heated just as we do in the normal or simple distillation. The mixture is heated. Now evaporation takes place. The liquid with lower boiling points will evaporate more easily. It will evaporate first. We collect it in the column. Once that boiling point is passed, we get to know that that liquid no longer exists in our mixture. Then we wait for the next one as the boiling point rises. As another constituent boiling point is reached, it will also evaporate and then it's collected. So we are collecting components of the whole liquid in bits. Okay, so that is a simple explanation for fractional distillation. We are collecting the components in bits, in fractions. Now when we have a solid mixture, okay, a solid mixture, a suitable solvent to dissolve one of the solids, is chosen. One of the solids, so here should have been solids, is chosen. In a case where one of the solids is magnetic, for example, when we make sulfur and iron filings, we can use just a magnet to separate the components. Now, after dissolving one of the solids, the mixture is filtered to obtain the other solid. The filtrate is evaporated to obtain the other solid. Okay, so let's say you have sand and salt. You just pour water into the mixture, you dissolve the salt, you filter to get the salt solution, then you evaporate the water and then you get your salt back. You dry the sand and then you also get your sand back. So you choose a suitable liquid to dissolve one of the solids, you filter and then you evaporate to get both your solids. Okay, so these are liquids for dissolving certain solids. Please take note of them. Solid and then suitable solvent. We have soluble solids, example salt and sugar. We can just use water. Gloss paint, we can use white spirit. Grease nail polish, we use propanone. Glue printing ink, we use ethanol. Okay, this is just like an alcohol. And then in summary, please draw this table. Okay, you've listened to how each process takes place. Now just pause the video here and draw this table. This is just a summary of what we did today. Filtration decantation is used to separate an insoluble salt from a liquid. Evaporation is used to separate a dissolved solid from a solution. Crystallization, a solid from a solution. Distillation, a solvent from a solution. Fractional distillation, liquids from each other. Chromatography, different substances from a solution. Please pause the video here, answer the questions, and that will be it for today. If you didn't understand anything, please draw my attention. Have a nice day. Bye.